Good day, everyone. Once again, Mlungisi Nkosi, your favorite uncle, and we are still continuing on that May-June supplementary exam. And yeah, I'm going to help you with the question 2, which obviously is based on organic chemistry. So if you haven't subscribed, please just make sure that you hit that subscribe button. And of course, if you need assistance with mathematics or science or physical science, you're more than welcome to get in touch with us. Our email address is info@mlungisinkosi.co.za. And please don't forget to hit that super thanks button, okay, just to say thank you to Malume for dishing out that incredible content. All right, so let's look at organic chemistry together. Right, so they say write down the letter that represents the compound. So in this case, we've got compounds A up until G. All right, so if I look at compound A, you can see that's a haloalkane. Okay, we can see we've got a bromine there. Okay, I'm just going to try and move that so that I can annotate. Okay, and then B, we've got a double bond, that's an alkene. Pent 2-ene, that's C. Okay, that's also an alkene. Okay, and D looks like an aldehyde. And we've got D, which is a ketone. And we've got an alkyne at F. And we've got an alkane at G. And we've got an alcohol at H. Right, so they say write down the letter that represents a compound which that is a ketone. Okay, please note that they said letter. So in this case, you would be incorrect if you wrote down the name or anything else. All right, so the ketone in this case, that would be E. Okay, goes without saying, that's our ketone, and we see the suffix "-one" there. This is not pronounced one, but it's "-one", right? That has the general formula, that's 2.1.2, that has a general formula CnH2n minus 2. Please note that's the general formula of an alkyne, right? Remember, for an alkane, you've got the general formula CnH2n plus 2. For an alkene, you've got CnH2n, and for an alkyne, of course, it's this one, CnH2n minus 2. So the only one that's an alkyne there is compound F. All right, and then the next one is an isomer of 2-methyl-but-2-ene. So it has to be a double bond. First of all, there has to be a double bond, so it has to be an alkene, right? So that alkene has got 4 carbons plus 2, plus 1 in this case. So 1 carbon and 4, so that's 5 carbons, and is an alkene in this case. I do think that that will be compound C. Okay, so 5 carbons in this case, and it has a double bond, so that will be compound C. And by the way, just to make sure that we fully understand that, in this case, this would be it will be not a positional isomer, but it would be a structural isomer, isn't it? We would say that's a structural isomer. It means 2-methylbutene, 2-methylbut-2-ene is a structural isomer of pent 2-ene. All right, so, or we can even say it's a chain isomer, right? Yeah, actually, I think chain isomer would be more appropriate. Right, and then the next one says has the same molecular formula as ethyl ethanoate. Now, please remember, in this case, what are isomers of, so this would be an ester. So the only compounds that are functional isomers of esters are carboxylic acids. So in this case, this isomer, or rather this ester, has got 2 carbons on the alcohol side, and it has 2 carbons as well on the ethanoic acid side. So in this case, it has 4 carbons in total. So we want an acid that has 4 carbons. So definitely that would be H. Okay, so that's 1, 2, 3, and 4. So in that case, it is an isomer of that ester. All right, now going to the next few questions. They say write down the IUPAC name of compound A. Now let's have a look at compound A. So compound A has got how many carbons? Let's see. It has 1, 2, 3, 4, 5, 6. Okay, could we have another combination? Doesn't look like it. And in this case, we see we've got a bromide there. Okay, so that would be at carbon number 3, right? No, actually at carbon number 2. So this would be carbon number 1, that would be 2, that would be 3 over there. That's 4, 5, and 6. Okay, and let's see, do we have a double bond or a triple bond? No, we don't, because that carbon has got 1, 2, it's bonded to another carbon. It has 4 bonds in total. Yeah, it looks like it's an alkane in this case, a haloalkane. So we've got a bromide at carbon number 2, right? So I'm going to say 2 bromo. Okay, B comes before the ethyl chains. By the way, I've numbered from left to right because it's closest in this case to the halogen, which in this particular case would be our functional group, right? So in this case, we're going to say this is 2 bromo. Please don't forget the hyphen between the number and the letter. So in this case, we always need to have that hyphen. So that would be 2 bromo. And then at carbon number 2, at carbon number 4, and at carbon number 5, we've got side chains in that case, and they all have 1 carbon. So this would be 2, 4.5, so 3, 4, 5. Remember, when I see 3 numbers next to each other, it means that they all represent the same thing, right? So how many do we have? We've got 3, so this is trimethyl. Sorry that it spills over like that. Okay, so 3, 4, 5 trimethyl. All right, and obviously now we go to the parent chain. Our parent chain has got 6 carbons, so in this case that would be hexane. Okay, right, so this is 2 bromo, 2.4, 2, 5, not point rather, it's a comma, right? 2, 4, 5 trimethyl hexane. Sorry, I should have made that into one word. Sorry, I couldn't fit that in there. Unless if you want me to, I can just write it over the other side. Yeah, let's just try and remove that there. Okay, so please remember that when you give that name, you always start with the side chains, or in this case, what we call our branches. So we said that's 2 bromo. So you always put them in alphabetical order. So 2 bromo, that's 2, 4, 5. We said trimethyl. Okay, please note every time between a letter and a number, in this case, there is that hyphen there. So trimethyl hexane. Okay, one word. Right, the next one says, write down the structural formula of compound F. So compound F. So when you write down, or when you draw the structural formula in this case, please, you always start at the end, right? So it means for my parent chain, I've got pent, which means I've got 5 carbons. And at carbon number 2, I've got a triple bond. So in this case, I've got 5 carbons. Okay. And at carbon number 2, I've got a triple bond, right? So that's the 2-ine. And at carbon number 4, I've got 2 methyls. So at carbon number 4, I've got a methyl side chain, and I've got another methyl side chain. And of course, now you can obviously put in all your hydrogens over there. Okay, just be careful about this one with the triple bonds, so we don't put any hydrogen there. Otherwise, we'd have more than 4 for the carbon. Okay, sorry that again it spills over, but I'm sure you get the point. Okay, right, so that is what it would look like at carbon number 1, carbon number 2, 3, 4, and 5. And at carbon number 4, we've got those 2 methyls, right? Methyl side chains. And as a result, we've got, that triple bond as well at carbon number 2. All right, moving right along. Okay, so now they say to us, for compound D, let's see what compound D is. Okay, that's our aldehyde. That's our aldehyde. So they say, write down the homologous series to which it belongs. Well, I've just said it. In this case, it belongs to the series called aldehydes. Okay, right, and then they say the name of its functional group. Please remember that the name of the functional group of aldehydes is simply called the formyl ion. Okay, or you can say the formyl group, formyl ion, or you can say the formyl group. Remember, it's that C double bond O with an H, right? But remember, they did not want the structure, but they wanted the name. Okay, so that's very important. Okay, so the next one, they say the structural formula of its functional isomer. Now, please remember that, the structural isomer, or rather the functional isomer of aldehydes are ketones, right? They have the same molecular formulae, but in this case, the position, or rather, the functional group is not the same. Remember that ketones have got the carbonyl ion, all right, and these ones have got the formyl ion, right? So they said the structural formula of its functional group, functional isomer rather. So I'm going to draw the structure. So that would be 4 carbons. So I can just simply take a ketone with 4 carbons, right? And it would have a double bond at carbon number 2. And it doesn't matter whether you chose from the left or to the right. The fact of the matter is that functional group should be at carbon number 2. In this case, it would be number 2 either from the left or from the right. Either way, it's the same thing. Okay, so that is what it looks like. If you chose to put that double bond O over this carbon here, nothing wrong with that. The fact of the matter is it's still the same thing. All right, so the next question, they say for compound G, so compound G is butane, they say write down the IUPAC name of a chain isomer. Now remember that chain isomers in this case, same molecular formula, same functional group, but in this case, one has a side chain, the other one can be a straight chain compound, right? So what would it look like? So that would be with 3 carbons. If you don't mind, please may I just remove this one so that I have space. I'm sure you've gotten the answer to that. Okay, so in this case, I would have, right, 2-methyl propane. Okay. In fact, they said the IUPAC name, sorry. Look at me drawing the structure. So that would be 2-methyl propane. 2-methyl propane. And please remember, in this case, you could even get away with calling it methyl propane because there's nowhere else that methyl can sit other than the second carbon in this case in order for it to be a chain isomer. right? Once it goes over to carbon number 3, then it no longer becomes a side chain, but it becomes part of the parent chain. Okay, right. And then the last question, they say write down a balanced equation using molecular formulae for its complete combustion. Okay, now please remember, in this case, butane has got the molecular formula C4H10, right? And what you should know is that complete combustion, we are reacting with oxygen, and the product is carbon dioxide and water. Okay, right. Now, what is left for us to do is to balance that out. Okay, so I've got 4 carbons on this side, so that means I would say, well, 4 carbons on this side, okay, to make it balanced. I've got 10 hydrogens on the other side, okay, so I would say, well, 5 multiplied by 2 gives me 10. Now what's left is the number of oxygens. So I'm going to simply say, well, how many oxygens do I have on the left? I've got 2, but on the right I've got 4 times 2, which is 8, plus another 5 times 1, which is 5. By the way, if you left it like this, you already have 2 marks if you are not able to balance it, right? But I still want you to get that extra mark as well. So how many oxygens? 4 times 2 we said, that's 8. We've got 5 times this one, that gave us 5. So the number of oxygens is 13. So in this case, this will simply be 13 over 2, because 13 over 2 times 2 will give us 13. However, please remember that you cannot leave the coefficient as a fraction or decimal place. So in this case, I'm going to just multiply everything by the lowest common denominator, which is 2 in this case. So it means everything is multiplied by 2. I just want to change color so that you can see that nicely. Okay, so this will be 2 times 1, which will be 2, right? And 13 over 2 multiplied by 2 gives me 13. Okay, so that would be 13. And then 4 times 2, which will give me 8. And then the last one, 5 times 2, which will give me 10. So in this case, that is our balanced formula. Okay, right. So I hope that makes sense. Once again, ladies and gents, it's been good. And I'll continue to just give you solutions to these questions. Please just make sure that you continue preparing, as obviously you've been doing, preparing for your chemistry exams. Okay, hopefully these lessons are able to help. Please don't forget to hit that super thanks. Tell your parents, hey, Malume would appreciate just a bit of appreciation. Just go and give him that super thanks, and that money will help us, to continue dishing out this lovely lessons. Otherwise, I'll see you guys again next time. Don't forget to also share with your friends and like. I'll see you next time. Shop, shop.